welcome back. I am going to finish or do the third part of our series of videos on significant figures. And this video is going to be about rules for multiplication and division, and also show you how to round properly. So at this point we know what significant figures are, and we know how to figure out how many significant digits we have in a number. And now we're going to use these when we do some mathematical operations. Alright, so for multiplication and division, how many ever numbers you have that you're multiplying or that you're dividing, okay, you have to follow some rules. So first off, I need to show the presentation to you. Alright. Okay, so if we have 2, 3, 4 multipliers, or it doesn't matter how many, we're going to look at each of our numbers and determine how many significant figures there are. Alright, so in 351.2 there are 4 significant digits, and for 5.5 there are 2. There are no zeros here, so everything's significant. So we have 4 and we have 2. So when you punch this in your calculator before this class, you would maybe round however you wanted to, or you would write the whole number out that you get in your calculator. Okay? Well, in chemistry and in measuring numbers, period, so significant digits are when we measure numbers, we have to round appropriately, and we have to use the correct number of significant digits to show how precisely we measured something. Alright, so we have miles per hour here. And so what you do, the rule is your answer from any of these transformations or operations is that you have to have the same number of significant figures as in your original numbers, which are these here. Always does that the first time. Okay, and with the fewest sig figs. Okay, that's just my shorthand for significant figures. Alright, so I had 4 and I have 2. So my answer has to have the lowest number of sig figs. So I can only have 2 significant digits in my answer. So this is not correct. Okay, I have to round to 2 significant digits. Alright, so what we do is I go out to the second digit because I need 2 sig figs. So I'm going to go and I'm going to look at this number here. Okay, so I have 2 numbers in my answer. Alright, and then I look next to it, and that's in blue. And I'm going to drop everything to the right of that number, that second sig fig. Okay, it's a number 8. So the rules for dropping and for rounding is if that number here in blue is between 0 and 4, then you're going to drop it and leave all the remaining digits. So round down, you might have heard, or just leave it as it is. If it's between 5 and 9, then you're going to have to round up. Okay, so look, I need 2 sig figs. Okay, that was set by looking at my sig figs in my problem. And if it's an 8, that means I have to round up. Okay, and so my answer is going to be 64 miles per hour. Okay, this is correct. And so on your homework and when you're working problems, you might think this is really picky. Okay, but what this is testing you in your homework and tests or whatever you might be doing with these is, do you know how to record numbers properly? Okay, this is important. Okay, that you didn't give me an answer of 63.845. You gave me an answer of 64, because that is the degree to which you were able to measure with whatever instrument you used the precision of that number. Okay, so it's very important that these are recorded correctly. Okay, so here's some more rounding tables. So let's just pretend we don't have a transformation or operation here, but we can just look, and we're supposed to round to 2 places. So I go to my second place, I look next to it, the number in red is 2. It's below 5, so I'm going to leave it as 61. Okay, if I need to round to 3 sig figs, I'm going to go to my third number here, and then I'm going to look to the right of it. Okay, and it's going to round up. So everything else is dropped. past that. So all these numbers to the right of that 2 are going to be dropped. Okay, but my 2 is going to be a 3. Okay, if the number is 5 and up, it rounds up. Okay, if I need to round to 4 sig figs, I'm going to go here, and I'm going to look next door to the number in red, and everything to the right of the 5 is going to be dropped. Since that number is a 3, then I keep that 5. I don't round it, I keep it as it is. I don't lower it or raise it. Okay, if I need 5 places, then I'm going to go 1, 2, 3, 4, 5. I'm going to look at that 3, and I see that next to it I have a 7. So 7 obviously greater than 5, so I have to round up. So I get 61.254. So this is just rounding, but it's showing you how to do this when you have a certain number of significant digits that you are supposed to report your answer to. Alright, so let's do some practice. Here's a couple of problems here. Both of these are multiplication. Okay, they could be division, so I didn't show any problems here. I'm sure in the book and homework there's plenty, but it doesn't matter. We could be doing multiplication, we could do division, we could do both in the same problem. But the main thing is you look at your numbers that you're given to start with, and I have 4 and I have 3 sig figs. Okay, and these are pretty easy. I have no zeros or anything, but be sure that you can do these with numbers that have zeros, and you have to use your sig fig rules. Alright, and so if 3 is my lowest number of sig figs, that means this number that's going to come up in my calculator is this really long number has to be rounded to 3 sig figs. So I go out to my third number, I look next door, it's a 7, so it has to raise that 1 up to a 2. And now I have 3 sig figs. Okay, is my lowest number in my problem, and then my answer is in 3 sig figs. And so we look next to it and round it, and then you drop everything that is to the right of that number. Alright, here I've got 5 sig figs and 2 sig figs. Okay, and also remember these would be measured numbers here. Alright, so if I look at my answer, there's my second digit, because I have to have 2. That's my lowest number of sig figs in my problem. I look next door, and I have a 9. So that's going to round that 8 up. So the 8 rounds up to a 9, and everything else is dropped. And this would be how you would do some calculations using the proper number and reporting your answers to the proper number of significant digits. Okay, I wanted to go ahead and add one with division in here. I noticed that as I was going that we should do one like that. So if you'll give me a second here. Okay, so I just made up this problem. We're going to take 101.67 and divide it by 0.00120. Alright, so if you put that in your calculator, I would get 84725. Okay, so the idea of this video is to see that that is probably not the way that I need to report this using the correct number of sig figs. Alright, so the same rules apply. We look at both numbers and we determine how many significant digits we have in each. Alright, so here I have 10167. All 5 of those are significant. Okay, remember those sandwich zeros in between non-zero digits are always significant. Okay, and then I look over here. Okay, and this one's kind of testing do I know my rules for sig figs? Okay, anytime you have leading zeros, they're out in front of a non-zero digit, these are not significant. Okay. However, the 0 here, because there's a decimal place in this number, this 0 is significant. Okay, and so in this total number, the 1, the 2, and the trailing 0 behind a decimal is significant. So we have 3 sig figs. Our multiplication division rule says that of all of our numbers that are in the problem, all of our dividers or multipliers, your answer is going to be reported to the number of sig figs with the fewest sig figs from the problem. So here we have 3, so we can only have 3 here. So I go to my 7 and I look next door to it and I see that there's a 2, which is less than 5, so this number is going to round down. Okay, and so when I round this down, okay, or round down just means basically keeping it the same. I also wanted to show this one because if you round this and keep it the same at 847, I get a lot of students will accidentally write this as their answer. Okay, that is not correct. Look how big this number is. You have 84,725. Okay, that number can't round to 847, so you kind of forget your common sense there just because you're used to dropping those numbers afterwards. But when you have a really large number with no decimal place, you can't just drop the numbers. Okay, and so what we do is we round to 84,700, okay, instead of 84,725. Okay, and so if you look here, we have no decimal place. So these 2 zeros here are not significant, and that would make sense because we were supposed to report our answer to 3 significant figures, and that's what we do. Okay, so this one's a little more, little bit harder, and I did this on purpose just to show you not to do this. Okay, when you have a large number like that, okay, you keep that 7 the same because the 2 is smaller than 5, but you can't drop those numbers off, okay, because then you're making it a totally different number. Okay, and so those numbers become zeros that are not significant. Okay, remember your rule for zeros. If zeros trail a non-zero digit, just like this, okay, if there's no decimal place, trailing zeros are not significant if there is not a decimal. Okay, so in this problem, we would have 1 significant digit. All of those zeros, not significant because there's no decimal place in that number. Alright, so I hope this helps, and I will see you in the next video. Thank you.